All right, so building on our previous discussions about ARP 4754A and ARP 4761, which set our system and safety foundations, we're now going to dive into the architectural framework that makes modern avionics possible and, more importantly, certifiable. We're talking about DO 297. Here's how we'll break it down. We'll start with the challenge that Integrated Modular Avionics, or IMA, was designed to solve. Then we'll get into the DO 297 framework itself, looking at its core ideas and the different roles it sets up. After that, we'll see how it fits in with all the other standards, and wrap up with what this all means in practice. So, to really get why DO 297 is so important, we have to first understand the massive architectural shift that happened in avionics. A shift that demanded a whole new way of thinking about certification. Historically, the name of the game was federated architecture. You can think of it as one function, one box. Each system had its own dedicated computer, its own little piece of hardware. Now, this was simple and it gave you natural physical isolation, but it came at a huge cost in terms of size, weight, and power, what we call swap. To solve that, the industry moved toward Integrated Modular Avionics, or IMA. The idea was to put multiple functions, sometimes with very different safety levels, all onto one shared computer. This was a brilliant move for efficiency, but it created a huge certification headache. How do you prove that all these different functions won't step on each other's toes when they're all living in the same house?
And that's exactly the problem DO 297 was designed to fix. It provides a rulebook, the accepted framework for managing all this complexity and ensuring everything stays safe.
So the standard itself is officially known as RTCA DO 297 in the US and EuroKE ED 124 in Europe. It was a joint effort to create one harmonized approach. Essentially, it's the definitive guide for proving that an IMA system is airworthy. Now, here's a really critical distinction to make. DO 297 is not itself a regulation. It's a guidance document. Think of it as an acceptable means of compliance, or AMC. By following the playbook laid out in DO 297, an applicant can build the case and generate the evidence to show regulators that their system is safe and meets the actual airworthiness regulations. And this table shows you exactly how that relationship works. You have industry bodies like RTCA and EuroKE that develop the standard. They write the playbook based on industry best practices. Then you have the regulatory authorities, like the FAA and EASA, who officially recognize that playbook through documents like advisory circulars. They're basically saying, yes, this is a valid way to show us you've met the requirements. Okay, let's get into the technical heart of DO 297. We're going to look at the actual mechanisms that ensure safety when you've got multiple applications sharing the same piece of silicone. The formal definition of IMA really centers on this idea of a shared set of resources. You have a platform, that's your hardware and some core software, that provides services like processing and memory to a bunch of different independent applications. So how do you manage the risk of all this sharing? The key technical control at the center of DO 297 is something called robust partitioning. This is all about building digital walls between the applications. It's designed specifically to prevent a fault in one application from spreading and taking down another, especially if one is much more critical to safety than its neighbor. And these walls, this partitioning, are enforced in two main ways. First, you have time partitioning. This guarantees that every application gets its assigned slice of the processor's time. It prevents a greedy or faulty application from hogging the CPU and starving the others. Then you have space partitioning. This creates protected zones in memory, so one application absolutely cannot read or write to another application's memory. No data corruption, no unauthorized access. But, and this is maybe the most important technical point to remember, partitioning is not a magic bullet. Even if your partitioning is perfect, every single software application still has to be developed and verified to its proper design assurance level under DO 178C. And the hardware underneath has to follow DO 254. Partitioning ensures safe coexistence, but it is no substitute for building each component correctly in the first place. Okay, so beyond the tech, DO 297 does something else that's incredibly smart. It creates a procedural framework to manage the complicated supply chain by defining exactly who is responsible for what. DO 297 sets up three very distinct roles. First, you have the platform supplier. Think of them as the landlord. They provide the hardware and the core operating system. And most importantly, they are responsible for proving that the partitioning environment, those digital walls, is solid. Then you have the application suppliers. They're the tenants. They build their specific functions and provide all the evidence, like their DO-178C artifacts, to show their app is safe. Finally, you have the system integrator. They're the building manager. Their job is to bring it all together, manage how resources are allocated, and do the final verification on the entire integrated system. So, with those roles in mind, let's see how this architectural standard fits into the bigger picture, how it connects with all the other systems, safety, and development standards that we rely on. You can really see how the whole certification process flows from top to bottom here. You start at the highest level with ARP 4754A and ARP 4761 to define what the system needs to do and what the safety goals are. That's where you assign your design assurance levels. Then, DO-297 steps in to define the integrated architecture that can host all those functions safely. And finally, you get down to the nitty-gritty of development, using DO-178C and DO-254 to build the individual software and hardware components that will live inside that architecture. This is why that quote is so perfect. DO-297 really is the architectural glue. It's the critical link in the chain that connects that high-level system safety case to the low-level evidence you get from building each component. It makes sure everything comes together in a way that's truly certifiable. Let's wrap up by looking at what this all means for actual aircraft programs and what the key takeaways should be for any engineer working in this space. For a program, going with an IMA approach has huge benefits. It allows for modularity, reuse of software, and you can even certify things incrementally. It also makes supplier responsibilities crystal clear. But, and it's a big but, it puts a massive amount of pressure on the system integrator. It demands absolute, uncompromising discipline in configuration management and in verifying those partitioning mechanisms. One little configuration error can compromise the entire safety argument. So, if you remember one thing from all this, let it be this. In the world of integrated modular avionics, the focus of certification has shifted. It's not enough to just prove that the code inside each individual function is correct. You now have to prove the integrity of the architectural contract, the rules of engagement that allows all those functions to live together safely on the same hardware. This framework really points to where things are headed. As our systems get more and more integrated, more software defined, the focus of our work has to expand. It's moving from just verifying what a single component does to verifying the integrity of the contracts that govern how all the components interact. Definitely something to think about. Thanks for watching.